Using non-rechargeable energy storage systems like batteries, capacitors, or supercapacitors to power IoT devices poses some challenges. The first problem is that when all the stored energy is depleted, the energy storage system needs to be replaced, which is a challenging task for large IoT networks and IoT nodes located in remote places that are difficult to reach. The second problem is the shorter lifetime of the node, that is, the time required to deplete all the energy stored in the energy storage systems. One of the essential goals when designing and deploying IoT nodes is to ensure that they can operate for several years without the need for any human intervention, minimizing the need for frequent battery replacement. Energy harvesters are integrated into IoT nodes to improve reliability and ensure IoT deployments' financial and environmental sustainability. The energy harvesters harvest energy from renewable sources, which can be converted into electrical energy. The electrical power generated is used to power the IoT node, and any surplus is stored in an energy storage system to be used when the energy harvester cannot generate energy due to unfavorable environmental conditions. The energy can be harvested from ambient sources such as solar and photovoltaic, radio frequency, flow, wind or hydro, and thermal energy sources. Ambient energy harvesting is the process of capturing energy from the immediate environment of the device and then converting it into electrical energy to power IoT devices. The ambient energy harvesting systems that can be used to harvest energy to power IoT devices, access points, fog nodes, or cloud data centers include solar and photovoltaic energy harvesting, capturing natural light energy in the case of light or artificial light in indoor deployments, and converting it into electrical energy to power IoT devices. Radio frequency energy harvesting involves capturing RF energy from the environment and converting it into electrical energy to power IoT devices. Flow energy harvesting, converting the energy generated from airflow, like wind energy harvesting, or water, hydro energy harvesting, into electrical energy to power IoT or other IT infrastructures. Thermal, capturing the energy generated from temperature differences and converting it into electrical energy to power IoT systems and other IoT infrastructures. Acoustic noise, capturing the energy from the pressure waves produced by a vibrating source and converting it into electrical energy to power IoT devices. Vibration energy harvesting, harvesting the energy created by vibrations like due to car movements, machine operations, etc., and converting it into valuable electrical energy which can be used to power IoT devices or stored in the battery for later use. Human body energy harvesting is harvesting energy from the human body and then converting it to electrical energy. The energy source could be the vibration or deformations created by human activity, temperature differences, or physiology. When designing energy harvesters for IoT nodes, it is crucial to consider the following design constraints. The availability of renewable energy sources. It is important to choose an energy source that is abundantly present in the IoT node's environment. An RF energy source should be chosen if the energy from RF sources is sufficient to power the IoT node. Otherwise, other sources like solar, wind, or vibration can be considered if they can produce sufficient energy to meet the IoT node's energy needs. Solar energy sources produce energy during the day and do not produce energy during the night. Intermittency of the energy sources. The energy produced by renewable energy sources varies randomly due to random fluctuations in environmental conditions. Energy sources such as wind and solar exhibit significant variability, which should be considered when designing or dimensioning the energy harvester. That is, the harvester should be dimensioned to produce sufficient energy in worst-case conditions. Size and weight. In some IoT deployments, it is required that the size and weight of the device should be as small as possible. This limits the type of energy harvester that can be used. It also limits the amount of energy that can be generated. The location of the devices. Solar energy can be used for outdoor devices, and artificial light may be used for devices deployed in indoor environments. Devices deployed in environments with abundant RF energy, like 4G and 5G, can harvest energy from RF energy sources.